chloride is associated tightly with one another due to opposite charges, right? And since here, when due to the hydration of ions, this sodium, due to the hydration of ions, water is neutralizing these charges, right? So in water, the interaction between sodium and chloride ions is lessened, due to which these sodium and chloride ions would not be able to recombine, right, to form solid sodium chloride, right? So that is why sodium chloride will keep in the dissolved state in water solution, because of this hydration of ions, because hydration of ions will neutralize the ions on positive sodium ion and negative chloride ions, right? Since charges are neutralized, so these sodium and chloride ions would not be able to combine back, right, to form solid sodium chloride. Now the next important thing is, when these ions are surrounded by water molecule, some energy is released, right? That energy is known as hydration energy, right? We call it as hydration energy, right? So as a result of hydration, some energy is released, which is known as hydration energy. And the second thing, important thing, is when this crystal lattice is broken, by water molecule, some energy is required, right? Energy is needed to break this crystal lattice. That energy is known as your lattice energy, right? And this energy to break this crystal lattice would come from hydration energy, which is released when these ions are surrounded by water molecule, right? Two things: this hydration energy which is released, right? And as a result of this released energy, this crystal lattice would be broken, right? And the energy required to break this crystal lattice is known as lattice energy, right? So in order for this solute to dissolve in solvent, this lattice energy, or we say the hydration energy, should be greater than the lattice energy, right? So for solute to dissolve, we say that solvation energy should be greater than the lattice energy. Then only solute will dissolve in solvent, otherwise it will not dissolve. Suppose lattice energy is greater than solvation energy, it will not dissolve. And the common example of such salts are silver chloride and lead chloride. We know that silver chloride and lead chloride are sparingly soluble or insoluble in water, because the lattice energy required to break lattice of silver chloride is high as compared to the solvation energy. We have less solvation energy that gets released, which is not able to break the crystal lattice of silver chloride or lead chloride, due to which silver or lead chloride doesn't dissolve in water, right? This is important. Now let's look the same from another aspect. You might be aware of Coulomb's law, right? We have already done Coulomb's law in physics, right? Coulomb's law is between oppositely charged ions, right? And here we have oppositely charged ions, right? Sodium ion and chloride ion, right? And we also know one thing. We call we say that water is a universal solvent, right? We have studied this in our previous classes, class 9th and 10th, that water is a universal solvent. Why? Because it dissolves maximum solid, liquid and gases in it. That is why it is a universal solvent. And what is the reason that it dissolves maximum solid, liquid and gases? Water has a maximum dielectric constant, right? We say water is a universal solvent, right? Universal solvent. This is because of high dielectric constant, right? High dielectric constant. And from Coulomb's law, dielectric constant is denoted by D. From Coulomb's law, we know that Q1 upon Q2 is upon R square D, right? This Q1 and Q2 here stands for sodium and interaction between this force of attraction between sodium and chloride ion, and D is the dielectric constant of water. Here, when sodium chloride is dissolved in water, the medium is dielectric constant would be considered for water, right? So this force, now just understand from this formula, since water dissolves sodium chloride, right? So basically from this we have already understood that when water neutralized the charges on sodium and chloride ions, when water surrounded these ions, right, and neutralized their charges, what it does is it reduced the force of attraction between sodium and chloride ions by neutralizing their charges, right? So water reduced the force of attraction between positive and negative ion, right, due to its high dielectric constant, right? Since force is inversely, from this relation we can see that force is inversely proportional to 1 upon D, and D is your dielectric constant, and water has a high dielectric constant, so it reduces the force between these ions, right? We have understood how, right, by neutralizing these ions. And since this Q1 and Q2, now if we look from here, force is directly proportional to Q1 and Q2, right? So what water did by neutralizing the charges, it lessened these charges, right? It neutralized these charges. This Q1 and Q2 charges are due to sodium ion and chloride ions, right? So water by surrounding, right? So water by hydration of ions. So what hydration of ions basically did, it neutralized the charges, and by neutralizing charges we mean it lessened this value of Q1 and Q2, right? So less is the value of Q1, Q2, less is the force between sodium and chloride ions, right? So since Q1 and Q2 has reduced, less Q1, Q2 means less force between sodium and chloride ions, right? So sodium chloride will keep dissolved in your solvent, which is water, right? So you can just take down all these notes. I have just summarized everything in these notes, right? Now the second thing that we have to discuss is the temperature. The factors that affect the solubility, nature of solute and solvent, we have understood. Now the second factor is your temperature. There are some solutes for which solubility increases with increase in temperature, right? And there are other solvents, there are other solutes for which solubility decreases with increase in temperature, right? So now let's understand this. For example, salts like potassium bromide, potassium chloride, sodium nitrate, potassium nitrate, for these the solubility increases with increase in temperature, right? So we say when we dissolve, say, potassium bromide, right, in water, it will form solution for potassium bromide. It will form this solution, right, solution of potassium bromide in water, right? And we say this is a endothermic process, right? This is a endothermic process. What is an endothermic process? The process where heat is absorbed, right? So when we dissolve potassium bromide in water, heat will get absorbed, right? And we say that when the temperature is increased, the solubility of potassium bromide will increase, right? So let's understand the reason why it increases. We know from Le-Chatelier's principle. Le-Chatelier's principle states that when a change is applied to an equilibrium system, whatever change we are applying, it will oppose that change. The change would be opposed. We'll understand it from example. So when we increase in the, just remember, this is an endothermic process where energy is absorbed in the forward direction, right? Energy is absorbed in the forward direction, right, and energy is given in the reverse direction, right? So when we increase the temperature, as per Le-Chatelier's principle, this increase in temperature would be opposed, right? So what this reaction will move in a direction where temperature is decreased. Since we are increasing temperature, Le-Chatelier's principle say that when temperature is increased on an equilibrium system, the reaction will move in a direction where heat is absorbed or where temperature is decreased. So it will move in a forward direction. So in forward direction, you can see that potassium bromide is dissolving in water, right, to form this solution of potassium bromide in water. So in forward direction, when we increase temperature, the reaction will go in forward direction, because in forward direction heat is getting absorbed or temperature is becoming less. So when we increase temperature, as per Le-Chatelier's principle, the reaction will